Today we are going to learn about arithmetic progression. So first we'll try to understand what is arithmetic progression, and after that we'll learn about some related terms. Right. So let's start with some examples. So I'm writing one example. This is 2, this is 4, 6, 8. You can see some pattern is going on, and if I ask you what will be the next number, so I think everyone can answer me that next number will be 10. Now we take some other examples as well. Let's say this is 1, this is then 4, this is 9, this is 16. So again you can see some pattern among these numbers. Second example, so this is 1, 4, 9, 16. I think you can think of what will be the next number. The next number will be 25, because the pattern is this is 1 square, this is 2 square, this is 3 square, this is 4 square, next will be 5 square, 25. Now take another example. This is -1, this is -2, this is -3, this is -4, and dash dash. So if I ask you in this example also, then can we find like which will be the next number? So next number will be, yes, -5. So that next number is -5. So after seeing these examples, we can have some more examples. Let's say this is 3 and this 6, then this is 10, and this is 14, and now. So can some of you think of the next number? See, first I have done 3 doubles. I have added 0 first time. So this is going to be this 3 and plus 3, 6. 6 plus 0 is 6. Then 3 plus 6 plus 3, 9. You add one more. So this is going to be 10. Then 10 plus 3, you do again 3, but this time you add 2 more. So you are adding 0 first, plus 3 means 3 plus 0 you are adding, then 3 plus 1 you are adding, then 3 plus 4 you are adding. So this way you can see that 5 plus 5, 3 plus 5, so 8, 23 will be the next number. So what is interesting about all these, we say them all these are the examples of sequence. So this way we have infinite number of examples, and there are infinite sequence of such numbers. But every sequence cannot be given name. So there are some specific sequence means numbers that you can see, and sequence also means when you can predict the next number also according to the pattern that you are seeing. So these are some examples of sequence. So there are some specific sequences. So first example we can take of arithmetic progression, and next there is another example I can give you. Let's say this is 2, this is 4, then 8, then 16, then 32. I think you can think of the next example. So this is something that you see that 4 if you divide by 2, answer is 2. 8 divided by 4, answer is 2. 16 divided by 8, answer is 2. 32 divided by 16 is again 2. So this is the example of geometric sequence. And this specific type, especially this one you see, there are some specific pattern, and that pattern is one particular number is being added every time to the preceding number. Like 2, we don't add anything in 2, but yes, 2 will be obtained. You have to start from 2, but next number 4 you have obtained after adding 2 to 2. Now 4, after 4 you again add that fixed number was 2, so you add 4 plus 2 is 6. Again you add that fixed number, 6 plus 2, this is 8. So this way you can go ahead, and this type of pattern when you observe, then this type of special pattern, and this is called arithmetic progression, or this also can be called an arithmetic progression. And if you want to define what arithmetic progression is, so it's very simple. Rather than indulge in words, you understand that in arithmetic progression next number is always obtained by adding a fixed number to the previous number. So here you can see in this example we are adding -1 to get -2, again -2, you add -1, this -3, -3 -1, again -4. So this way we are going. So now we are coming to the, because this chapter is about arithmetic progression, so we'll discuss in detail about arithmetic progression only. So your general form, now I am going to write general form of arithmetic progression. So progression means, you can see the word progression means when you go after and after and after. So that means the progression. And the general form is, let's say the first term is a, the next term a will be a plus d. D is the number which you add always to the preceding term. For example, here 2 was the d, 2 plus 2 4, 4 plus 2 6. So you are adding always a fixed number to the preceding term. So next, if you add a plus d, you add d again, so it becomes a plus 2d, a plus 3d, and now this way. So this is the general form in which a is called first term, and d is called common difference. So now next thing is, can you think of what will be the next term, and after that what will be the next term? So you see, this is your first term, that is denoted by, you can say this is a1, this term is denoted by as a2. A2 is very a2 is down, 2 is down. So and this is your a3 and this is your a4. And similarly, if you keep going on, there will be a time when you will be getting some last term, or you can say that as nth term. So this is called nth term. This is called fourth term. So those who are able to identify the pattern, the person can himself or herself write that an. You can think of how. I just give you the idea. See, whenever it is 2, the multiple of d, the coefficient of d is 1. Whenever it is 3, a3 we are talking about, the coefficient of d is 2. Whenever it is 4, means fourth term we are talking about, the coefficient of d is 3. It means whenever we talk about the number of term, your coefficient of d will be 1 less. And you can see a is everywhere, a plus d, a plus 2d, a plus 3d. So in general term, your a will remain there. But as I told you, if it is 4, here it is 3. Means whatever term you are taking, you will be getting 1 less. So if I am saying nth term, then I have to take 1 less, the coefficient of d. So n minus 1, and this is d. This is the general term formula. So an, I can write this as a plus n minus 1 d. So you can just put into this rectangular box and try to understand what is this. It simply means, if I ask you what is a 9 term, means a ninth term, if I ask you, simply you have to put n equals to 9. So this will be a9, a plus 9 minus 1, this is 8d. So if you get a sequence, you will get the value of a, you will get the value of d. So let's try and understand with one more example. Let's say this is 5, this is then 11, then 17, and then it is 23, and so on. So you see, this is your first term, this is your second term, this is your third term, this is your fourth term. So if I ask you, tell me the 10th term. So for 10th term, you need to see, you cannot write this sequence up to 10th. You cannot go like this, because this is 10th. Okay, you can go manually, but if I ask you a to 100, means 200th term, then this will be very difficult to find with this help of, like, you can make this more for more numbers. So better we have to develop the method through which you can find any sequence in between. So here you see your A is 5, and how D is calculated. You calculate from next whatever term, you take the previous term, you take the difference. And similarly you also see this way, arrow I am putting so that you can understand that 23 minus 17 you have to do, 17 minus 11 you have to do, 11 minus 5 you have to do. So in all this difference you will see that there is a common difference. That difference is 11 minus 5, that is 6. So once you get A and D, now it's very simple. And if I ask you to find A10, that you know this formula, in this formula I'm just going to put n equal to 10. So when I put n equal to 10, then A10, this is A plus 10 minus 1, this will be 10 minus 1 D. So this is going to A, you have the value of A is 5 and 9, 10 minus 1 is 9, and D is you have value 6. So this is 9 6 ja 60, this is 54, 54 plus 5, this is 59. So your 10th term is going to be 59. So in this the coming exercise we'll be discussing only these few things. We'll ask you what is the common difference, what is the first term, or you check whether this is an AP or this is not an AP. Okay, now let's discuss about some examples given in exercise 5.1. So in this example you have to check whether this is an AP or not. Simple as that. So question is, the taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So the fare, you see the sequence, you make the sequence of fare then and decide whether it is an AP or not. So you know that for first kilometer you are going to pay 15 rupees, and after covering second kilometer, means 2 kilometer, you will pay 15 plus 8, that is going to be 23. Then third kilometer you will be paying as 15 for the first kilometer, and for 2 kilometer you will be paying 8 rupees. So 2 into 8, and this is going to be 23 plus 8 you do, that will be 31. And for fourth kilometer you will be paying 15 for the first kilometer, and for rest 3 kilometer you will be paying 8. So this is going to be 39. So you see, you write the numbers 15, these are the total fares, 23 and 31 and 39. Now the question is whether this is an AP or not. So how do we find whether this is an AP or not? First of all, you can see that this is in the general form. A, this 15 will be your A. So this is A, then A plus D, 8 will be your D. So A plus D, A plus 2D, A plus 3D. So this is forming that general form. So this is an example of AP, but some of you can verify it another way. So if I do 23 minus 15, this is going to be 8. If I do 31 minus 23, the answer is going to be 8. If I do 39 minus 31, the answer is going to be 8. So this way you have seen that all the time the common difference is coming same. It means this is an AP. And if somebody asks you what is your first term, then first term is your 15. What is your common difference? So common difference is 8. And using the formula of general term, you can also find the fare after completing certain number of kilometers. For example, if I ask you after 10 kilometer how much you have to pay, so rather than adding this way, you can use the formula and apply the formula and you will get the answer. Now come to this question number 2. Write first 4 terms of AP. First 4 terms you have to write. So you see this is 10 and this is A is 10 and D is also 10. So you know that the general form is A plus D, A plus 2D, A plus 3D. You have to add D in every next number. We start from 10. So 10 and then a plus d means 10 plus 10 we do. So this is going to be 20. Then 20 plus 10 you do. Next number you are adding. So 20 plus 10, this is going to be 30. Then 30 plus 10, this is going to be 40. So this way you can find the terms, or you can use, I have used like in every previous term I have added d and then I am getting the next term. You can use this way also. How you can use this, like suppose this is I'm using different color for this next way. So this is 10 and next will be 10 plus 10, next will be 10 plus 2 into 10, then 10 plus 3 into 10, then 10 plus 4 into 10. So you can also write that as 10, this is 20, this is 30, this is 40, then 50. So either you go with this way or you go with this way. So you must have the understanding of both, because both are required. Now come to this fourth part. A is -1, D is 1/2. So now I'm using whichever method you say, I can use this. So this is -1, next will be -1 plus 1/2, then -1 plus 2 into 1/2, then -1 plus 3 into 1/2. Now we can simplify, this is -1 and this is going to be -1/2. You would see this is 2, this is going to be 0, then this is 2 and -2 plus 3, this is 1/2 and so on. So this way we can find the next, like they have asked to find 4 terms. Now consider this third question. For the following APs, write the first term and common difference. So you can see this first term is A. So you can say that A equal to 3, and D, you know how to obtain D. So you go 1 minus 3. So you always take 2 consecutive terms. So the next one you subtract the previous one, so you'll always get the difference. So this difference is -2. So here this is A is 0.6 and difference will be D will be 1.7 minus 0.6. So you know this is going to be 1.1. So this way you can find the common term, common difference and first term. Now next, question number 4. The question is which of the following are APs? Which are the APs? First you have to decide whether they are AP or not, and if it is AP, then find common difference D and write 3 more terms. So how do we check? So you see that 4 minus 2 you do, this is going to be 2, then 8 minus 4 you do, this is going to be 4. So here in just 2 example you can see that difference is not coming same. So it means it is not an AP. It is not an AP. So this we have decided. Now come to this 0.2, 0 and 0.22, 0.222 like this. So again you see, if I want to find, this is 0.22 and minus you do 0.2 and you can write 2 from your side. So this is going to be 0.02, right? Next you can see the difference. This is difference, will not write common difference. This is just the difference we have found. So we'll find another difference, 0.22 minus 0.22. You can write that as also this. So this you find the difference. So 2, this is 2, 0 is 2, then 2 to 0 and then 2 to 0 again coming this. So it seems like this is an AP, but this is not an AP, because you've seen the difference in first 2 terms. You see this is 0.02 and here the difference of third and second term is 0.002. So again it is not an AP. It is not an AP. Now you can see this example also. So this example you observe that if you find the difference here, this -1/2 and minus -1/2, so it will be 0. Again you find the difference here, again it will be 0. So your difference is coming the same, whether it is 0 or whatever number, but difference is coming. So you can see that it is an AP. Yes, it is an AP. So A is minus 1 by 2 and D is 0. Now come to this 1, 3, 9, 27. So if I find the difference 3 minus 1, this is 2. If I find the difference 9 minus 3, this is going to be 6. So again not an AP. AP nahi hoga. Now in this example you see some of you might say ki A square minus A is, so A square minus A is not A. It's you may take just common A minus 1, and now A cube minus A square, you do the difference, then A square can be taken A minus 1. So check whether both are same or not. So you can see that not, they are not same. So it is not an AP. It is not an AP. So you may see some more examples. This is your root 2, root 8, root 18, root 32. So first of all, do not do that mistake that root A minus root B is equal to root A minus B. This is not any rule. So this is not true. So you cannot apply this rule. So root 8 minus 2, if you do directly, then you will not get root 6. So you have to think little bit more in a constructive way. That is root 2 is root 2. Okay, root 8 is actually 2 into 2 into 2 3 times. So pair you take outside, then this is then 9 into 2. So 9 into 2 means 3 into 3 into 2. So you take outside, then this is this, and this is 4 root 2. Now you can see very clearly that difference is always coming same, because now these are all like terms. So when they are like terms, you can find the difference. So A is going to be your root 2 and D is 2 root 2 minus root 2. It's going to be root 2. So here both A and D are same. So now next, last this example, 1 square, 5 square, 7 square, 73. Okay, you might say this is not an AP, but don't be in hurry. You think what are these number actually? This is 1, this is 25, this is 49, and this is 73. So you find difference. 25 minus 1 is 24, and 49 minus 25 is again 24. 73 minus 49 is again 24. So it means A is, this is an AP, this is an AP, and A is 1 and D will be 25 minus 1, and this is 24.